co-founder of Topology, and I am here to talk about making games on StarkNet. And I figure that the people in this crowd may be less familiar with StarkNet, much more familiar with Ethereum, and so I'll give a brief intro on what StarkNet is. But first of all, why make games on StarkNet? So the question boils down to what exactly is StarkNet? In short, StarkNet is an operating system of sort, and it runs on top of the Cairo virtual machine. And it basically posts validity proofs of the state diffs of StarkNet onto Ethereum. Right? So it essentially serves the purpose of scaling Ethereum and be a layer 2 for Ethereum as a layer 1. Now, Cairo is a keyword, right? So what is Cairo? Cairo is the smart contract language for you to create a smart contract on StarkNet, and it stands for CPU Algebraic Intermediate Representation. I often think that the O is missing, so maybe we should just call it CARE. Cairo, CARE, the smart contract language for StarkNet, and it's a Turing-complete, Stark-friendly architecture. Right, so the question boils down to what is Stark? And StarkNet, Starkware, just a lot of confusing terms. Stark is scalable, transparent argument of knowledge, is a zero-knowledge proof technique to prove computation. And I think it's actually important as we are in 2022 to understand that this is a generational revolution in the trends of technology. As in, with these zero-knowledge proof system popularized, we can write provable code. Like, computing is very, very abundant, right? Everyone has smartphones. Smartphone has the capacity of launching a spacecraft to moon many decades ago, but now everyone has that same computing power for playing Angry Bird at your fingertip. Right? But so compute is very abundant, but provable compute is very scarce. And blockchain is all about provable stuff. Right? On layer 1, you can prove that someone transferred money from account A to account B. You can prove that someone owns certain liquidity in a liquidity pool in a protocol. Right? It's all provable. But layer 1 has its problem because it's rerunning everything across every node. It basically achieves security by rerunning everything, maximizing security, but pretty bad for efficiency. But that's okay because now on layer 2, specifically ZK rollup, we can run provable computation. And so complex logic can run on layer 2 and only the proofs will get to layer 1 and be posted on those very expensive real estate. Right? And I think it will be also interesting to talk a little bit about Stark before we go into the games, because whatever we make on ZK rollup will be based on this new computing paradigm. And so it's fruitful and useful to understand what are these machines and mechanics that you're working against. They are not just another bit packing binary machine that we all program on. These are mathematical machines in a sense. My favorite example is, imagine you want to prove to your friend that you calculated 1 million terms in the Fibonacci sequence. And so you basically go to your friend and say, yo, look at this huge number. This is the millionth term in the sequence, right? And how would your friend trust you, right? Blockchain, we don't trust, we verify. So how would your friend verify that big number? Well, the naive way would be for your friend to rerun everything from 1, 1, 2, 3, 5 all the way to the millionth term, and then say, okay, I arrived at the same conclusion as yours, so I know you're not lying. This is essentially the layer 1 blockchain model. Things get rerun, right? So not very scalable. Zero-knowledge proof systems in general are these dark magic construct that allow you to do very little thing, but you can verify that your counterparty is not lying, they're honest. And so coming back to the Fibonacci sequence example, how do you prove to your friend that you've computed 1 million terms of the Fibonacci sequence? Well, the particular way Stark does this is, imagine you have a long column in your Excel spreadsheet and you put all these million numbers on a spreadsheet, right? And what it does is it finds a polynomial that passes through these points. So you have 1 million points. You basically find a very complex, weirdly shaped polynomial that passes through all these million points. Okay, so you now have a polynomial that connects these dots. But that's not enough, because Fibonacci sequence is not just any random number. It has relation between consecutive numbers, right? It's basically, term x plus term x plus 1 equals term x plus 2. So you want to also find all these polynomials between these term triplets, right? So now we have a bunch of polynomials. We have one huge polynomial that are connecting all the middle numbers, and we have a bunch of small polynomials that describe every two numbers adds up to the next number, right? And then we have some dark magic way to compress all these polynomials into one single polynomial, and then we can have some weird way of transforming it into a very low degree polynomial. Low degree is important because that's how the magic is done. As in, the verifier can do very little thing, but still verifies that you're honest or you're lying. Okay, so imagine all these dark magic happen. Imagine that I pack all these information, right, a million numbers and all these Fibonacci relations into a low degree polynomial. How would you verify that? Say if I know a degree 1 polynomial, which is just a straight line, that encapsulates this entire information. The way you would test me is you would say, okay, I'm going to evaluate 2 points on your polynomial. Those 2 points will give me a line, right? And then I'll evaluate a third point. I will make sure that that third point lies on the interpolated line. If I do this for enough times, then I have a confidence that you're not lying. You actually know a straight line that encapsulates all these complex information, right? And if we have a low degree polynomial, say if degree 1, you basically need to do 2 points, interpolation, and then plus another evaluation. These are very simple compute. But if you can do this, you can really verify very complex information. And so this is how Stark system does it. It transforms all these complex computation into magical polynomials that can be verified in a very efficient way, right? So if you can verify efficiently, you can scale, right? You can really scale what you cannot do on layer 1, but you can do on layer 2. And the magic here again comes from, if you can do this recursively, you can imagine doing a layer 3 on layer 2, where the layer 3 post-proof on layer 2, it gets packed onto the layer 2 state. And then the layer 2 state, again, do some stuff on that state and packs into another proof and put it to layer 1, right? So imagine just mentally going to an upper layer will give you recursively more and more compute. And at year 2022, we're just at the cusp of having a layer 2 that uses this dark magic. Right? So imagine if we can have another layer every 1 year. By 2032, we will go to layer 10, maybe. But technology always evolves faster over the long term than we estimate. Right? So pretty bullish on this trend. Okay, so these are mathematical machines. Right? So why run games on StarkNet? Why program games on a mathematical machine? I'm going to share a couple mental models that we have as Topology. The first mental model is on these compute machines, you want to compute more and store less. Right? So a bad thing to do would be to create these rich and beautiful 3D environment assets in a Blender and then try to upload it to StarkNet. StarkNets and blockchains in general, they're not Dropbox, they're not your storage space. They're supposed to handle provable computation for you. So the good thing here is to create some algorithms that could procedurally generate rich environments for you. That would be the interesting thing to do on these provable computation medium. And the interesting thing is, if you can come up with these algorithms, then every time you run that, it will generate the same algorithm. No one can really tamper with the topography or the structure of these environments getting generated. No one can tamper it, right? So you have a tamper-proof, immutable environment in which participants can interact in. That's pretty good. As opposed to, this goes back to why make games on blockchain at all? And I think we all understand that without making games on blockchain, game devs themselves are gods to the game. And if human organizations play God to any world, that world is by definition temporal. You cannot create a world that will rely on human beings to organize and rule and still wish that it can run over arbitrary period of time. Right? So creating worlds that can regulate themselves in a provable way is the way that we're all bullish for, and that's why we're making games on blockchain. And coming back to the conclusion, blockchain is not for storage, so you want to compute more and you want to store less as much as possible. Mental model number 2 is, I think it's important to recognize that we as humans, we're all off-chain. Like we, compared to blockchain, we're by definition always off the blockchain. We're not the first-class citizen on the chain. What is first-class citizen on the chain? It's smart contract, right? So you can't really prevent bots. Bots are by definition the first-class citizen, the native citizens in these worlds. We, as humans, interact with the blockchain through all kinds of Oracle devices, right? Your VR headset, your controller, your console, your touchpad, your mouse, your keyboard. These are Oracle devices that are interfacing with the blockchain. And so, one thing to notice that here is that humans always have off-chain computation they can fall back to. So what does this mean? This means that if you run like a computation problem on StarkNet and you want people to find solution for it, you have to recognize that people can always go to have access to their supercomputer, which is just the regular off-the-shelf regular machines, and they can compute stuff in a very efficient way, and they can come to the blockchain and post solutions. But you can't really constrain them. And so, what do we think about here? Number one, I think it's important that we don't differentiate between human and bots. It's just we are actually external beings to the blockchain world. Number two, I think it's important to make problems NP hard so that algorithms have a hard time finding automatic solutions to it. It relies on humans to come up with heuristics to deal with that, and that's what humans are good for. So this is actually friendly to human in a way. Number three is, you can think about injecting randomness to the problems from player-generated actions. So what does this mean? This means that if I'm running a world that is deterministic on the blockchain, you can basically predict that people can take that world off-chain and just forward it over arbitrary time frame and predict everything deterministically. They can then come to the blockchain and basically behave like gods because they know what will happen. All right, so one way to prevent this from happening is you want to inject some randomness to the state transition on the blockchain, and you want to tie that randomness to something that's very hard to gain. Right? So if you tie that to player-generated action, which means that you are incorporating player-generated action into a seed that will generate a random number that will influence the next state, then as players, we have two options. We either gain that randomness, but we're making suboptimal decisions, or we're making rational decisions, but we give up gaming the randomness. And I think rational players will go for the second one. Right? So that's one thing to think about. And the fourth thing, thought to maybe think about is think about imposing constraints from an execution environment. So this is actually specific to StarkNet. So with StarkNet, every transaction you send, there is a resource upper limit, the amount of compute you can carry out in a single transaction. Right? So you can say, well, I as a game will accept player-generated algorithm. So for example, you can create a maze game, and you can say, player come to me and they can implement their own pathfinding algorithms that can solve the mazes. But on StarkNet, every transaction is limited by the amount of resource that's allocated to it. Right? So that's actually placed a complexity bound on top of the user-generated solutions. You can say that I'm only accepting your algorithm if you can if you can solve the maze within a given transaction. Or you can even take up spaces in that transaction a priori so as to giving less space to the player-generated algorithm. So there are funny things you can do with it. But you're basically leveraging the constraints provided by StarkNet. Mental model number three is information asymmetry. So as gamers, we're very familiar with it, right? So for example, take Fortnite as an example maybe. You as players are constantly generating information asymmetry for yourself, and you basically extract that, right? So every time you go to a hiding place, every time you create something that you know but your players don't know, then you're creating an advantage for yourself. That's basically asymmetry between players. Another kind of asymmetry is between players collectively and the unknown, and this is the Isaac game that we presented this morning. It's about players working together against something that's unknown to all, and therefore they need to work together. I think there is a third kind of asymmetry that is very strong and thus far unexplored, which is between players and game devs collectively against the unknown. And this basically means that the game developers are making a game whose underlying logic is unknown even to the game developers. And maybe we can call this a truly fair launch game. Like game developers themselves, as human beings, also do not have an edge, right? And this is actually a very hard problem. On StarkNet, you don't have this out of the box, but there is interesting research going into creating zero-knowledge system that will allow you to collectively holding secrets of the universe, but no one single-handedly can solve the secrets of the universe. So in a sense, everyone is fairly participating and interacting within the universe. Another mental model is we have the code is law situation again, right? Many years ago, we have the code is law debate. Ethereum forked by then. I think we now have, again, the same problem, code is law, but in this context, we have code is the law of these simulations or game worlds that we are creating. So an example will be Soft-to-Mint. Soft-to-Mint is something that Topology created with Matchbox style, and it is basically a physics puzzle created in Chiral contract on StarkNet. And so you're supposed to submit solutions to, the website is right there. So if you go to that website, it has a input form for you to submit solution. And on the back end means StarkNet on a blockchain. It will verify your solution by running the entire physics simulation and check that if you have a good solution. And good solution means that you're solving a physics puzzle with a score, with a non-zero score. And if you look at the leaderboard screenshot here, you have all the top players scoring about 600 points, which is kind of ridiculous because in the physics game, every time you achieve an objective, you actually earn a point between 10 points and 20 points. And the simulation doesn't run long. So from first principles, we know that the scores should not be above 100, even 600. So this is a case where players figured out a way to gain the lack of continuous collision detection in the particular implementation that this physics puzzle has. So without those collisions, you can actually find really weird angles and momentum where your physics puzzle appear to be static, but you're scoring a lot of collision events frame by frame by frame. And by that, you can score a ridiculous amount. But in a sense, you're not actually solving a puzzle, but again, because code is law, so anything that a smart contract accepts will be legal by definition. So it is interesting to think about this old problem coming alive again. Next mental model is real depth. So real depth basically means that we believe games are not games actually on a blockchain. Games are more like worlds in themselves. And if you want worlds, then you want worlds with depth. Because depth supports the space of creative expression. And what do I mean by that? Right, this reality has really tremendous depth. But the physics is super deep. The mathematics are incredibly deep, and they're just our mental model of understanding the mechanics of this universe. Right, so it's super deep. And the implication of that is we can do all these wonderful things. These human creations are all based on our understanding of how the mechanics of this universe, right? And we are deriving technologies from those understanding, and we can create all these UGCs, these user-generated content. So if we're creating worlds on the blockchain, and blockchain is all about provable stuff. It's not just random computation running in a game developer's own server, right? These are on a blockchain, provable stuff. It's valuable to build worlds where you really build depth into it. Next mental model is multi-ingress and inclusivity. This basically means that if we are going to build metaverse where people with different backgrounds, interests, talents basically find their place in this world, then you want your world to have multiple ingress or multiple entrants. So, for example, the Isaac game that we described this morning, people with interest in solving optimization problems, they can come in. People with interest in thinking about orbital mechanics can come in. People with interest in solving human coordination problems can come in, because Isaac is a game about massive collaboration. It's all win versus all lose. And mental model 7 will be permissionless expansion of game boundary, and this is actually very core to what blockchain uniquely enables that traditional game industry cannot provide. Permissionless expansion basically means that you can play a game, and you're not actually just player as a user. You can help create and expand what people can and cannot do in the game. And on the blockchain, the really interesting thing is everything is running in smart contracts. So imagine players can deploy their own smart contracts that, when connected to the game contract, actually expands the boundary of the game. So the more players submitting their own contracts, providing more information utility, you have a game that's grown by the player, right? And in a sense, it's not player anymore. These are citizens of your world. They help growing and increasing richness of your world. This is very unique to blockchain as a medium. But I think that for many different reasons, including smart contract languages are not really good languages, etc., we have a lot of bottlenecks. But the coming decade, we're bullish of solving those bottlenecks. We're all about building the metaverse. And the last mental model we want to share is striving for non-skeuomorphic ideas. We've discussed about this morning. Layer 1, what Layer 1 did to financial industry, we believe Layer 2 and Layer 3 upwards will do to the game industry. It's decoupling the game industry. It's rethinking how these human-created simulations with human-defined rules and behaviors should be built. And so translating game mechanics and genres that we're all familiar with from our past 3-4 decades playing video games directly to blockchain may not be the best way to go. The best way to go may be thinking from first principles, understanding what these mathematical machines really are, and starting from there, experiment through trials and errors, finding the native game mechanics that are fun and at the same time leveraging the medium itself. And if you can leverage the medium itself, your mechanics can scale when the medium scales, right? If you're just transpiling something of an old age to a new medium, then when the new medium becomes richer and more efficient, your mechanics don't really benefit from that. And so it's always better to build native than building in a skeuomorphic way. Especially in this zero-knowledge proof revolution, where this medium will scale 1,000,000x or even way more than that in the coming decade. It's a wonderful time to think about skeuomorphic ideas and build now. Lastly, I want to talk a little bit about Matchbox DAO. If you're new to Cairo, they are a wonderful entry. They are a DAO where a bunch of Cairo developers, new and experienced, they're building open primitives for game industry, for on-chain game industry. This is quite contrary to the financial domain. In the financial domain, projects more or less are playing the zero-sum game. They're competing for liquidity, they're competing for trading fees. But for the on-chain game domain, primitives work together, and so it's a positive-sum game. The more primitives there are that are interoperable, the richer game mechanics can be built on top of these primitives. And Matchbox DAO is trying to curate that environment for developers to come and share and build together things that can interoperate with each other. And we are co-founding Topology. Again, Topology is, the mission of Topology is building zero-knowledge proof system research and also creative work and engineering innovations so that we can really build on-chain worlds and on-chain realities with really strong interoperability and composability. And if you're interested in thinking non-skeuomorphically, then talk to us. Thank you.